Hello everyone, my name is Todd Morrill and I'm a machine learning scientist at PwC, a large professional services firm. Our emerging technology lab explores and develops AI-based procedures for our clients as well as for internal tools and applications. This work is an exploration of how to assign semantic labels to entities found in text. This has clear applications when modeling a new domain in which we have no labeled data or ontology. Procuring such a labeled dataset requires a tremendous amount of effort on the part of human annotators. As you may know, the named entity recognition task attempts to assign a semantic type to entities found in text. These things might be like a person, an organization, a location, or finer grained entity types. These typed entities can then represent nodes in a knowledge graph and enable deeper reasoning about the content found in text. So our procedure works as follows. We extract proper nouns from sentences in the training portion of our corpus. We then embed these phrases using a BERT-based model, cluster the embedded phrases using k-means, and analyze the results. Here we sample a few phrases from each of the clusters and it becomes clear that they're fairly coherent. At this stage, we could attempt to automatically label these clusters using techniques such as key phrase extraction, but having a human review a dozen examples from each cluster may yield the best results and lead to some novel insights about the domain that you're modeling. Co-NLL 2003 is a research dataset containing news articles that have been annotated with named entities in one of four categories. They are location, miscellaneous, organization, and person. Since we have a labeled test data for Co-NLL 2003, we were able to evaluate how well this procedure worked. If you don't have labeled data, you could label as much test data as your labeling budget will permit and evaluate how well your pipeline performs on this manually curated set. So, as you can see from the table, this procedure does a terrific job separating entities from non-entities, as you can see from the O class, which is the set of non-entities, but the performance varies across the actual semantic labels. Finer-grained cluster labels, hierarchical cluster labels, and contextualized embeddings may improve these results further. In terms of applications of this work, this procedure can be useful when exploring a new domain where semantic types are unknown a priori. This could also serve as a first step in bootstrapping a labeled dataset and defining an ontology for this new domain. These labels could also be useful as signals for training a weakly supervised model. Another application for this work is relation extraction, where we could basically follow the same procedure, but instead of extracting entities, we would extract spans of text between entities and then cluster and assign semantic labels to the clusters. So in summary, this work provides a practical procedure for modeling new domains and creating a corresponding knowledge base, which unlocks the potential for AI systems that can more powerfully reason about data. Thank you for listening.